Hello, I'm Jeremy Meyer. I'm coming from Nice on the French Riviera, and I'm part of the Amadeus Data Management R&D department. About Couchbase, we have just finished our tests. We have did 2 months of tests to assess if Couchbase would be appropriate solutions for many of our use cases. Now, let's have a look about what is Amadeus' mission. Roughly, we want to be the leading provider of IT solutions that enable success in the travel and tourism industry. But practically, what does that mean? Here is one of our roles. We are a GDS, that is a global distribution system. What is that? We take a huge pile of contents that you see on the left, from airlines, from car companies, from hotel, from rail, from cruise, from insurance. We take all the tourism and travel data, and we take it in our side, and then we distribute it to other actors of the travel and tourism industry. To name a few, we have travel agencies, as you know, with travel agents and so on, with as well corporations, websites, where you can book your travel solution within your company. And we have as well the provider sites, like airline.com, where you can book whatever solution you need about car, hotel, and whatever. And as well, we distribute to airports. That's roughly one of our roles. Now, a couple figures about our operations to give you an idea of the scale about which we are dealing with. We have 3.7 million bookings done per day on the system. And by the way, what you see here is our data center at Erding. And to do those 3.7 million bookings per day, we have 1.6 billion transactions per day happening on the system. And for all those transactions, we have many database accesses, up to 45 billion accesses per day. So you see the ratio about how many DB accesses you need to finally have a booking. The DBs are really stressed. We have 13 petabytes of storage. And globally, we have a response time less than half a second. And all that in a system that undertakes more than 100 changes per day. So the system is constantly changing. And of course, no service outage is permitted. Now, let's take a look to the technical context in which we did the Couchbase tests. We are a very big system. We could even say gigantic, but yet agile. We are continuously taking several migrations at the same time, and we have a lot of features being added to the system at any time. We have thousands of R&D software developers pushing new features. About our philosophy, about NoSQL and new SQL solutions, they are very welcome for us. We are struggling with RDBMSs since years, and we see in a very good view new solutions able to help us in our challenges. We are using massive Memcache deployments since 2009 as an example. And from what we started during the test campaign, we had a general enthusiasm from R&D community as a starting point, and we were willing to completely understand how Couchbase was functioning. We are aware that there is no perfect solution, that there is no silver bullet, and that's okay. Now let's take a look to the next part of the presentation with the agenda. So now I will go roughly through our architecture. Then I will detail some of our motivations to test Couchbase. And finally, I will demonstrate 2 use cases, Amadeus Selling Platform Connect and Amadeus Availability Processing Engine. Then wrap up. Here is roughly our architecture. You have on the top right providers, data coming in. In below, you have our enterprise service bus that we developed fully in-house. And on the bottom, you have our central system with all our applications dealing with the travel and tourism industry. On the top left, you have the consumers of all of this with the UIs, internet, and all of kinds of accesses to the system. The central system on the bottom is mainly made of a C++ platform with a homemade framework. And on the top left, on the access part, they are mainly architectured around the Java technologies. The two use cases I will detail are one part from the central system on the bottom, and the other one being part of the access layer, being the selling platform Connect for travel agents. All of this is, as you have seen, a service-oriented architecture. What are our interests in Couchbase? We are looking for a low latency key value store. We are really interested in the low latency key value store at this point more than in the document management or in other richer query model. What kind of properties are we looking for here? We are looking for performances. We would like sub-millisecond latency, for instance. We are seeking for a system exhibiting cross-data center replication, for instance, up to 50 data centers. We need a system elastic, since we have a huge traffic growth on a regular basis. We need regularly to extend capacity, and we need the system to be elastic and to allow smoothly to change topology. We need the system allowing the data to be persistent so that we don't lose it and we can recycle application without cold booting. And this, we need to have the support with the write traffic of a very high intensity. We like about Couchbase the aspect that it's open source and that it is near of a memcache. Since we have experience with memcache, we appreciate this aspect. Another aspect that we enjoy is that we have a company as a provider to rely on. That is support, training, quality insurance, and so on. Now, let's go to a bit of theory about the CAP theorem. This theorem says that any system can only exhibit two of these three properties. That is, out of partition tolerance, consistency, and availability, any system can only have two. Maximum two. It could have less, but maximum two. Partition tolerance being the system being able to resist to two nodes not seeing each other. Like if a network faces an issue, a system with a P property would still resist. Consistency being the property for all the clients seeing the same data from the system. And availability being the property for the system to always answer something to the people requesting. Either answering OK, answering KO, answering anything, but answering something. And in Amadeus, we have for some application strong need for consistency. And for some others, we need a total availability. Of course, we would like to have all our system both strongly consistent and totally available and partition tolerant. This is not possible due to the fundamental issue with the distributed systems. Now, let's go to the two use cases. The first one is Amadeus Selling Platform Connect. What is it? We can say it's a travel arena for professionals. It's a website used by professional travel agents, which leads to it having several constraints that regular website doesn't have. Here it's a website for travel agency, which are professionals, and it's their business to use this tool on a daily basis to make the job. So we have constraints about consistency which are much higher than for end users, as we will see for the second use cases. Here we have 500,000 terminal. You can see this as the places where you can buy a travel solution. And we have up to 150,000 simultaneous users on the system. All those users have a session that usually lasts very long. The travel agents enter in the travel agency, start this session, and will keep it all day long. So the sessions are long-lived. And on total, it's a half a terabyte of user session data that we need to manage, with the strong constraint that this is a product for professionals. So, what's the motivation for this system to rely on a distributed key-value store? We wish to offload the user sessions, which are currently stored in the JVM, to a distributed, scalable, and robust system. And this will allow to reduce the total cost of ownership by allowing the machines to be used completely. Now, there is resources on the CPU level which is wasted and which will never be when session will be offloaded. And as well, with the constraint that the user experience shouldn't be degraded even if the sessions are no more stored within the JVMs but are stored on an external system. Here is a view of the test architecture we have put in place for testing Amadeus Selling Platform Connect. So we have a web server, we have a Java EE cluster, and we have a cache cluster, which in this case was a Couchbase. The methodology was to simulate real users using the system and checking what the real users is getting as system experience. We used the Java Smart Client, and we have a specificity here, is that a given session stored in a given Couchbase node is only used by one process, one node of Java EE. Now about the results of the test we did around Couchbase. On performances, this was okay. The user experience was good, no degradation, everything okay. On network and CPU consumption, all fine. About operational test, let's see. Adding a cache node, extending the capacity, went okay. And stopping and starting the Java EE nodes was very fine. And stopping and starting cache nodes, here we had something different. We discovered that when more than a node is down, we need to take a manual action. And we discovered something different, is that when a node faces an issue, we have 30 seconds where the service is no more available until the failover is performed. This can be overcome thanks to usage of node affinity, where the session can be stored locally on the client until the failover has been done on Couchbase. Globally, Couchbase can be an appropriate solution for Amadeus Selling Platform Connect, and this will allow to sustain much more traffic with less Java EE nodes. Let's go to second use case, the availability processing engine. Does this ring a bell? Websites exhibiting flights with price, dates, departure dates, and everything. Each time you see this, most of the time you are targeting Amadeus. And here we have a view of the system behind this. On the top, you have the pricing and shopping platform, which is directly targeted by the website. And itself, it targets the availability processing engine, which contains all the data cached from providers of various kinds. This is a big shield for the providers like airlines, car and rail. And this is really our most intensive application with a key value need. Currently, we are using 28 RDA BMSs on this side, and we have 20 terabytes of data. In the peak traffic, we have nearly 2 million gets of objects per second. And about writes, it's 400,000 sets per second. And the objects are not that small, it's 1 kilobyte in average. Here is the test configuration of the availability processing engine test. So we had 7 application servers on the test environment. Production is more than 300. And on the Couchbase side, we had five nodes, each with 1 terabyte of RAM, and we're using PCI Express SSD cards. The test methodology here was not to simulate real users targeting the system, but it was really taking real production traffic injected on the test platform. And as we have just seen on a Skyscanner, we are using Moxie for this test, and we had no code change on the API side. Now, let's look to the test. So this is a throughput test where we increase gradually the traffic up to a point here where we reach 32 sets per second. And then below, we see the disk write queue, which at this moment started to grow. And it grown because of a thread being at 100% CPU. This is something that can be improved, and then the node will be able to scale further. Here we had, on a single node, 9% of production traffic, which is very nice, and it was handling more than 100K gets per second and 33K sets per second, which is quite impressive. Let's take a look to a data rebalancing test. That is, we have on the top added a node, and on the graph below, we have added and removed a node simultaneously. And we see the volume of data contained in the node. Each line is a node. At the beginning, we had 4 nodes with roughly the same data, and progressively, as the new node was getting the data stored in the new node, we have all the lines roughly being at the same level at the end. It worked fine. And on the other side, we have one node, the one being removed, that gives this data to the other one. And finally, the 2 nodes will have exchanged roles and will have been swapped. On the normal node adding, we have 7 megabytes of bandwidth. And on the smart node change as well. And for our nodes of 1 terabyte, it would be 40 hours, which may sound a lot, but considering currently we need 2 weeks, 40 hours is fine. Let's look at the cold boot. That is, you have a node completely stopped that restarts and read again its data from disk. That's where having data persistency is useful. One of the cases where it's useful. And here, what do we see? We see here that we have a full outage. That is when we stop the node. That's okay. And then the node reads again the data from disk after the outage. And while it is reading the data on disk, the service is degraded. And we have seen a service degradation of 15 minutes. And then the service was back to normal state. So globally, we had 20 minutes for the node to perform its cold boot. Considering the volume of data, that's not bad. about the backup and restore test, which are key abilities for a key value store for us. On the top, you have the backup, and on the bottom, you have the restore. So we have seen it's functional and stable. It was really not showing any surprises. We had 9 megabytes of bandwidth to perform the backup. So for 1 terabyte, we will need 30 hours. And on the restore, we were restoring 21 kilo documents per second. So for our 1 billion documents, we would need 12 hours. Let's look at document fragmentation compaction test. So at the beginning of this test, we had not enabled the mechanism to compact. Here, the mechanism was not enabled, so we see that the fragmentation increases a lot. And here, we have activated again, and we see that it really works well with the fragmentation dropping drastically. Let's look at the test of cross-data center replication. So here, we were injecting at 16 kilo sets per second. And we are seeing on the bottom graph that the volume of replication changes left is increasing. And we have seen that we are able to replicate 4K documents per second. So that's why the volume of data to be replicated was increasing. The outcome of the AP test. Couchbase definitely looks appropriate for AP. And it will allow to decommission the 28 RDBMSs, which is something very nice. But before going to production, we have a follow-up ongoing on a couple points. For instance, to have the writing to disk not limited by the CPU, by a single thread, so that we wish it to become multi-threaded, so it uses more of the resources of the box. And as well, to prevent service outages, we wish to have the ability to read the data replica of the master node, even if this may create a problem of consistency. That's fully okay for the availability use case. So we have high expectation on Couchbase 2.02 and Couchbase 2.1. It's time for the wrap-up. Globally, we have seen global compliance with our demanding expectations. On the product side, performances were good, stability was good, feature set was good. We will start very soon to experiment with the Couchbase 2.0 features. And we enjoyed the care for enterprise matters. For instance, all about migrations and API stability. On the other hand, about the support, thanks to Perry, we got very skilled and involved support, and the immediate matters we had to sort out were sorted out very efficiently. And we enjoyed as well the information on the upcoming changes coming on Couchbase. What are our expectations on Couchbase evolutions? On the core features, we are looking for ability to tune about how much highly available and how much consistent we are. We are willing to get a better usage of the CPU resources of the boxes, for instance, by multi-threading the queues consumptions. And we are curious about what kind of benefits we could get with the PCI Express SSD direct access. On the management features, here is what we are looking for. We are looking for the fire cell concept. That is, when you have a data center with several parts which are fully independent, you are willing typically to get one copy of your data in one area and the other copy not in the same area, somewhere else, in another independent area. That's what we call fire cell. We are looking as well to get tunable routing policy for cross-data center replication. That is not always replicating a full bucket, but a sub-part of a bucket based on a rule or on a regular expression or something, but not the full bucket. We are seeking as well to get several processes per host, mainly for test systems, so that we can consolidate on a given host. We are looking as well to support heterogeneous farms, having in the same cluster some big machines and some small machines. And typically, the small machine would be simply older machines. And as well, we are willing to get an ability to not invalidate data from a failed over node. This is useful for one of our applications that is not performing any data update, but only inserts. So we have no risk of compromising consistency, because if the data is there, it means it is the correct data, since it could never have been updated. So in this case, discarding the data after having failed over a node is not useful. And as well, we are keen and would be happy to read more in detail about the inners of Couchbase, about the process and thread models, about how the data is stored to disk, and as well about incident management and troubleshooting guides. Let's conclude. We have seen that we have very strong data management needs, and we are globally in a very demanding industry. And what we have done is that we have assessed Couchbase in many applications, and critical ones during a 2-month period. We have seen that Couchbase is solid during all those tests, and it's really a good candidate to support our business with the version 2.02 or 2.1. I think I have a couple time for questions.
So you talk about being able to have a node fail out of the cluster and bring it back in without resetting from an empty data set. Do you see in your deployments, lots of instances of network unavailability or otherwise, like having nodes become unavailable for short periods of time, and not necessarily Couchbase, but just in general? Is that a network problem you see at scale?
Network issues are something real. Even in a private data center, they exist and may tend to show that a node is not there, whereas actually it's only an illusion that the node is not there. It happens. Yeah. I think considering the volume of data is not that bad, then if it would be like 5 or 10 times better, we would of course enjoy it. We haven't seen any Moxie issue. No. We haven't really stressed Moxie on those tests. Moxie was running on the application server, and it was not as stressed.
You mentioned that a failover took about 30 seconds. What problems did it cause you, and what is your expectation?
Problem is first that there is no more service during those 30 seconds. For instance, on the availability processing engine, with 2 million get per second, we would have 60 million requests not served. So that would be the problem.
So what's your expectation?
And here on this use case, reading the replica, the copy of the data, that's fine. And then we know that there is some barrier that we cannot overcome, especially about some inner aspects of the network. That is, we cannot expect a failover to happen in less than 2 seconds. This is not possible. The complete data set. Yes. Yes. Thank you.